Diagnostics. This is part 6 in our series on macro experiments. Last time we sketched a macro named SF symbols, which took a variadic number of strings and produced an enum called SF symbol, where the cases were named for the strings. So for example, this expands to the enum SF symbol, which has cases corresponding to each of the entries. So here's circle, and here's arrow right, and please note that arrow dot right is transformed into arrow uppercase R for right for our case. The macro also creates this computed property name, which makes it easy for us to use this when we create an image. So if we have this SwiftUI view sample view and it has a body which only contains an image, we can specify the system name as sfsymbol dot one of the case names dot name. And this is great. In our own calling code, it means that we can't make a mistake by typing in the wrong string. There is, however, the possibility that when we create our SF symbols using this macro, we could enter a name that isn't valid. In this case, we'd like helpful feedback at this point to flag the invalid name. So for example, I'd like to see something like this: cannot find an SF symbol corresponding to, and then actually tell me what the symbol is that I've typed in. We'll accomplish that using Swift Diagnostics. In a way, they're similar to errors, but in a way they really aren't, because more is required in the structure, and you'll see that. So let's create a diagnostic message, which is a type that is part of Swift Diagnostics. So we'll import Swift Diagnostics and we'll create SF symbols diagnostics, which is a diagnostic message. It doesn't need to be an enum, but I'm going to create it as an enum here. A diagnostic message must have a message, which is a string. It must have a diagnostic ID, which is a message ID, and it must specify the severity, which is a diagnostic severity. So here we've stubbed out our diagnostic message. In our example, we'll only have a single case. It is an invalid symbol name, and we'll pass it the string so that we can use that in our diagnostic message. Message is a computed property. It's going to return a string. And so we switch on self even though there's only one case, because that allows us to bind to the string. We'll call the string name. And this allows us to provide the diagnostic message, cannot find an SF symbol corresponding to whatever that name is. If the user chooses a name that doesn't correspond to an SF symbol, that should be an error. So let's set the severity to .error. And finally, we need to provide the diagnostic ID, which is a message ID. We'll again switch on self so that we can bind to the name, and in our message ID, the domain will be my library macros, and the ID will be whatever the name is. So we've created our diagnostic message. Now let's use it. So we create our diagnostic in our Swift syntax for a specific node, and we also have to provide a message. Once we have a diagnostic, a context issues it. So let's see what all that means. You might remember from last time when we were assembling the cases we were going to return from our macro, we looked at the argument and then processed it to extract all of the strings. And then for each string, we produced the corresponding enumeration case, and then we put them all together into the cases that we were going to return. The additional step this time is once we have each string, we're going to check that they're actually a valid name for an SF symbol. If it's valid, we have to return the input string so we can continue through our chain. If it's not valid, the context will issue a diagnostic and will still return a string. So here's the signature of the check function. Notice it takes a string, it takes a node, it takes a context, and it returns a string. So for now, you can imagine that we check that the string is a valid SF symbol name. And if it is, we just return that name. If it isn't, then we're going to generate a diagnostic, and we're going to create a diagnostic for a specific node, and we're going to have a message, and the message will be that SF symbol's diagnostic type that we just created, the invalid symbol name case for that, and we pass in the invalid string name. Once we have our diagnostic, we call context.diagnose and pass in the diagnostic as the argument. So that's the important part, but for completeness, let's return here and see what we mean by checking to see if the string is a valid SF symbol name. Unfortunately, we can't do this in SwiftUI, so we have to use platform-specific code. If we're on the Mac, we can use NSImage to tell us whether this is a valid symbol or not. Otherwise, if we're in iOS, we can do the same using UIimage. And that's the end of our checking. It's a little more complicated than I'd like, but it's still not too bad. But that's just a detail. Let's focus on the important part. The important part was we created a diagnostic using the node and a message. The message itself used our special type that we created, our SF symbols diagnostic, and the case invalid symbol name using the string. And then we threw the error, or in this case, the context diagnosed the symbols error, and that's how we issued our diagnostic. On the receiving end, that means if we enter an invalid name, this should be an error, and in fact it is, and we see the error message, cannot find an SF symbol corresponding to invalid name. And that's a quick look at some of the basic features of diagnostics.